morning, HOD Professor sir, my seminar guide Dr. Rahman sir, my seminar coordinator Niti Sharma sir, faculty member, examiners and my students. I am Shubham Gocher, pursuing my BTech from University Department of Mechanical Engineering, Rajasthan Technical University, Kota, Rajasthan. Today, I am here to present topic of my seminar presentation on hydroforming advancement in recent times. These are the topics of my presentation. Let's start with the introduction. Hydroforming is a metal forming technology based on the application of pressurized liquid media to generate defined workspaces from tubular material or sheet metals. Beginning of hydroforming. Hydroforming tools were born as a result of arduous research and development of the Cincinnati Milling Machine Company, founded by Geiger and Holtz in 1889. By the 1930s, the Cincinnati Milling Company was the main supplier of the metal forming machine in the US and Europe. As the demand for shaped metal parts increased, the Cincinnati Milling Machine Company began the process of developing deep rose forming techniques, used lightning reflectors and gear case covers. The image in the slide shows the hydroforming machines. The evolution in hydroforming took place when the company was transferred in 1956 to Cincinnati Milling Micron, and research development of the hydroforming process accelerated. The allowed more advanced form of hydroforming to begin and take shape. As a result, the old type of deep rose became obsolete and more modern hydroforming technique began to take the helm. By the 1970s, hydroforming was officially out of its fledgling stage. This hydroforming machine reduced the need of excessive metal part finishing, which in turn reduced the turnover time of the product, increased efficiency, reduced the workspace needed for produce quality products. Hydroforming divided into three categories. First, tube hydroforming. Tube hydroforming consists of a tube which is placed inside the two half dies of reverse shape. Then pressurized liquid enter from axial direction into the die material, gets expanded due to its pressurized sheet, and give desired shape. By this method, called welding process like welding get eliminated. Not only it makes complex shapes, it also minimizes the cost of manufacturing the product. Second, sheet hydroforming. Sheet hydroforming is a process progressive made the modern manufacturing industry and lead it to better state of equality into what to get deeper depth drawing. In this sheet metal plane, it's placed inside. The one of the die is replaced by pressurized feed and applying pressurized feed to get the geometry of cavity die. It consists of male and female die which prepared as punch cavity die. In this different method, it used like punch and cavity sheet hydroforming. Direct and indirect fluid contact hydroforming. Third, shell hydroforming. It's a new technology which is used to make spherical components. In these parts are welded from exterior with other parts to form spherical and oval shapes. Then pressurized fluid is passed through it due to that it is spent and bulges out. In this process, die is not used. It's a die-less process. The image in the slide shows the systematic diagram representation of tube, sheet, shell hydroforming processes. Industrial application. Hydroforming process are applications in industry as diverse as aerospace, automotive, cookware, and medical share one thing in common. They all benefit from hydroforming distinctive metal forming advantage, cost effective and focus on quality. In automobile industry, while hydroforming technology is currently used in the manufacturing sector of many different industries, the development has been pushed most notably by the automotive industry, which has used hydroforming technology to improve the manufacturing process of many different components. Many of the structural members of the automobile are now made by manufacturing methods that include hydroforming. Tube hydroforming, example of this which include cradles, pillars and undercarriage. Undercarriage for vehicles were previously made of U-shape or channel section carefully shaped and then welded or riveted together. The U-shaped section were produced by rolling, bending sheet metal or directly rolling a U-shaped channel and cutting and welding it to others. Furthermore, because the weld is compromised in the design, it will induce a change in material properties, and it's often a source of increased manufacturing cost and potential defects. This means welds require thicker section and wider segment, which add cost and weight. Tube hydroforming remove this problem as it allows for tubes to weld instead of welded, while in tubular shape, then expanded to final geometry, while become more rigid through strain hardening. In aviation and aerospace industry, hydroforming is an ideal option for aerospace component manufacturing process. Because of this complex nature of part produced, sheet hydroforming is a process that was primarily developed for the needs of the aircraft and aerospace industry. In this industry, lightweight parts play a major role which can easily made by this process. Material used in hydroforming process: steel, strong and affordable, durable, easy to bend, and will be last long time if maintained well. Stainless steel, it's also strong, durable, and corrosion resistant, difficult to cut and bend. Some jet engine components are made of stainless steel, aluminium, lightweight, steel, and corrosion resistant. More difficult to bend, not as strong as steel. Aluminium and its alloy are used to produce aerospace aerosol cases, oil filter pans for the helicopter market, and the lens treated. Nickel alloy are used for parts in the nozzle system, nose cones. Titanium, good strength, resistant to erosion corrosion, very thin conductive oxide surface film, hard smooth surface that limits adhesion of foreign material surface from a drop by its condensation. Titanium is used for component of portable water tanks. Copper, it's a high ductile, corrosion resistant, good machinability, and malleable. Advantages of hydroforming: first, surface finish. It provides good smooth surface finish. Second, waste reduction. By repeating the process, you eliminate waste from dented or accidentally bent parts, and less material is needed to consolidate for the section into one assembly. Third, lightweight parts are hydroforming produced. Lighter parts as required stiffness can be achieved using thinner walls. In previous process, this was not possible. But more complex shapes can be achieved from pre-bent tube by hydroforming, and they can even inlet and outlet opening incorporate. With it, improve efficiency. Automobile and aerospace vehicles. 6. Reduce tool cost. The number of tools or reduce can be done to fewer sections and the eliminate of the burring and punching process. Hydroforming having certain limitations. First, multiple bends. If a tube has one or two sharp bends, then it may be possible to use axial feeding process. But if part has more than two, the axial feeding in the center part of the tube becomes virtually impossible. Second, sharp bend. With the tube hydroforming process, sharp bends will require large pre-bending operation prior to the hydroforming, which will consume permeability, limit axial flow. Third, deep drops. Deep drops, which are exceptionally deep, are difficult to create, and many require many steps or steps leaving annealing stages. Fourth, sharp radius. It's very difficult to bulge or draw material into a tight internal radius or around a tight external radius without tearing. Fifth, excessive bulging. There is only a certain amount that a tube is physically capable of expanding, and this expansion is done by the material property, the initial grain size, and the final geometry. Development in hydroforming process. Hydroforming process is an advanced manufacturing process. This growing of this process is very fast in modern world due to its advantages over cold forming process. These are mainly research is going on to make this process more efficient. Different type of material and their alloy are used in this process, which has great mechanical properties. Automobile and aviation sectors. Lightweight design is extensively explored and utilized concept in many industries, especially in aerospace application and associated with green aviation concepts. The contribution of aviation to global market and phenomena and environmental pollution has led to ongoing effort for the reduction of aviation emission. Approach to achieve this target include increasing energy efficiency and effective way to increase energy efficiency to reduce fuel consumption is reducing the mass of the aircraft. As a lower mass requires less lift force and thus during flight. For example, for the Boeing 787, a 20% weight saving resulted in 10 to 12 improvement in fuel efficiency. In addition to reduction of carbon footprint, light performance improvements such as better acceleration, high structural strength, stiffness, and better safety performance could also be achieved by lightweight design. The principle of lightweight design is use less material with low density while ensuring the same enhanced technical performance. A typical approach to achieve lightweight design for aerospace component is to apply advanced lightweight material on numerically optimized structure, which can be fabricated with appropriate manufacturing methods. As a result, the application of lightweight materials can effectively achieve both weight reduction and performance improvement. Use of different materials. Although metal material, especially aluminium and its alloys, are still the dominant material in aerospace application, composite materials have received increased interest and competing with aluminium alloy. In many new aircraft applications, titanium is also used. Hybrid incremental sheet hydroforming. Nowadays, modified form of conventional incremental sheet hydroforming process is in demand, which is known as hybrid ISF. Thinning of sheet metal is crucial in ISF. Research are nowadays focusing on this process. So instead of solid Supporting tool pressurized hydraulic fluid is used in this process. This process is known as single point hydroforming. Conclusion: hydroforming is a great technology used to produce complex shapes, have to reduce pollution, reduce manufacturing cost. That's all. Any question?
Yes. What are its advantages over metal stamping process?
As you know, design can easily change in this process. It gives high versatility regarding design. This gives good surface finish almost near to the final process. Any other?
No.
Okay then. Thank you and have a nice